Good afternoon, my YouTube viewers. In this particular video, what we're going to start is a series on the distributions that are used in hypothesis testing. And the first distribution that we're going to talk about is the normal distribution. So the normal distribution, also known as the Gaussian distribution, is one of the most commonly used probability distributions in statistics. It is symmetrical, bell-shaped, and characterized by two parameters, being the mean and the standard deviation. So we're going to go through a practice question for the normal distribution covering the mean test scores. So we're going to test whether the mean test scores of students in a school differs from the national average when the sample size is large, being n is greater than 30. So the population mean is 75, and the class size is 50, and the sample mean x bar is 72. So the sample mean is 3 points lower than the population mean. Sample standard deviation is 10. The degree of freedom is 0 because it's B6. See, sample size, I don't know why we said B6 minus 50. It's B6 minus 1. The degree of freedom is 49. Confidence level is 95. And the z-score is B7 minus B5. So that's 3 divided by B8, which is your sample deviation. So your z-score is negative 0.3. So the null hypothesis is the mean equals 75, and the alternate hypothesis is the mean is not 75. And so we check our z statistic. It's B7 minus B5, and so that is the population mean minus the sample mean divided by the sample standard deviation divided by the square root of the sample size being 50. And so that's a negative 2.12. Critical value is 1.59 because it's norm.s.inv brackets 0.975. And the reason why is you have a confidence level of 95. So you've got 2.5 points on the one side and the 2.5 points on the other side. That gives you 0.975. And your p-value is 0.33895. So the decision rule is if B16, that's your z-test statistic, is less than negative B17, that's 1.95, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. And so we're going to reject the null hypothesis, which means that the mean is not equal to 75. And you can also check the p-value because the p-value is less than 0.05, where an alpha or confidence level would be, or significance level would be 0.05. That tells you that the p-value is less than 0.05, which is your alpha or your significance level, and that means that you would reject the null hypothesis as well. And then so what we did was we actually made a graph so you can see the graph. So the values is -4 to +4 and 0.1 point intervals, and you've got your norm PDF, that's probability distribution function. So norm.s.dis brackets D5 is your population mean, and it's going to be false. And then so we create the normal distribution, and then what we do is we create the statistics to go along with the normal distribution, being the plus critical z value is 1.95, the minus critical z-value being negative 1.95, and your test statistic being negative 2.132. And so your normal distribution is in blue, your plus critical z and your minus critical z is in red, and your test statistic, your z-test statistic, is in purple. So you can see that the z-test statistic is outside of the region of the minus critical value. So that means you have to reject the null hypothesis. So that's just a visual representation of what we were just discussing. So the next video is going to be about a t-distribution and how it relates to hypothesis testing and distributions. So I hope that you decide to watch it.